Welcome. Whether you're a student struggling to grasp these concepts or a professional looking to refresh your knowledge, this presentation provides mechanical engineering students with clear and concise explanations of solutions to problems in mechanics of machines. In this first module, we'll be diving into the fundamental concept of inertia forces in reciprocating parts, and this is our second example. Right, a horizontal steam engine running at 240 revolutions per minute has a bore of 300 millimeters and stroke of 600 millimeters. The connecting rod is 1.05 meters long and the mass of reciprocating parts is 60 kilograms. When the crank is 60 degrees past its inner dead center, the steam pressure on the cover side of the piston is 1.125 newtons per millimeter squared, while that on the crank side is 0.125 newtons per millimeter squared. Neglecting the area of the piston rod, determine the force on the piston rod and the turning moment on the crankshaft. Given the speed of the engine is 240 revolutions per minute, the bore D is 0.3 meters, the stroke L is 0.6 meters, the crank radius R is half the stroke, which is 0.3 meters. Small n is the ratio of the connecting rod to the crank, and that is 3.5. FL is a piston load, and Fi is inertia force. So the first thing we do is calculate the area of the piston, which is given by pi d squared over 4, and that gives us a value of 70,685.83 millimeters squared. Force on the piston, Fp, is given by equation 1, and piston load is given by equation 2, and when we plug in the values, we get FL to be equal to 70,685.83. Then Fi is given by equation 3. Therefore, Fi we get to be equal to 4,060.63 newtons. And from equation 1, we know that Fp is equals to Fl minus Fi. We now have the value for Fl and Fi. When we plug in, we get Fp to be equal to 66,625.2 newtons, and that is our answer. Next thing we do is to calculate the value of phi, which is the angle between the connecting rod and the horizontal, and we get the angle of inclination phi to be equal to 14.325 degrees. Turning moment of the crankshaft is given by equation 4, and when we plug in the values, we get the answer to be equal to 19.86 kilonewton meter, and that is our answer. Thanks for watching. Like, subscribe, and share.